Okay, let's get started. I'm Renuka, Product Marketing Manager here at NextMove, and I will be your host for today. Today, we will be diving into route optimization for package and parcel delivery. And I have the pleasure of hosting Joe, our solutions engineer. So here's a quick glance at what we'd like to cover. We'll look at common business logic for package delivery problems. We will build and deploy a custom package delivery model together. We will walk through a few considerations to keep in mind when you choose what to optimize and how often to run your model. And lastly, we will of course save time for Q&A. So please drop your questions into the chat box or use the Q&A feature. We will monitor both and spend a few minutes at the end answering them. So with that, Joe, I will hand it over and you can take it away.
Great. Thanks so much, Rainu. Thanks everybody for being here. Before we dive in, we're going to take a quick look at what a package delivery problem typically looks like. So the goal of this kind of a problem is usually to deliver all packages from a depot or warehouse with the fewest vehicles possible and in the shortest amount of time or distance while meeting all other constraints. It's relatively straightforward, but I want to make sure we have an agreement on what that looks like. So the typical inputs for this kind of problem are vehicles and stops. We've made a few assumptions for the sake of this tech talk, just to simplify things and make our model a little bit easier. Yours will likely look different because you have unique business rules and constraints. But we're going to assume here that our vehicles are something like trucks or vans, but you could obviously be doing this with something else like a bike or other kind of vehicle. And also, of course, we have our stops, which are simply delivery locations. So let's look at a few common package delivery constraints. We typically will always consider capacity. In our case, capacity is just number of packages, but you might measure that by weight of the vehicle or volume or some other measures. We're looking at driver shifts. So drivers are typically going to leave at a certain time of the day, and then they're going to have to be back to the depot by a certain time at the end of their shift. So we want to make sure we plan routes accordingly based on those times. We have start and end locations. In our case, and in many cases, this is the same because it's a depot or warehouse where all vehicles leave from and come back to at the end of the day. And we also are going to look at a few penalties. So because we want to use the fewest vehicles possible, we have a penalty on vehicle usage so that we only use a vehicle if it's needed. And we're also going to add a penalty for unassigning deliveries because we want to deliver all packages. And on the stops, we're going to consider stop duration. So you have to account for the time that it takes to stop the vehicle, deliver the package, and get back in the vehicle and get going again. So we'll consider that. We're also going to use time windows. If you're delivering to businesses, you want to make sure that you deliver at a time when the business is open, for example, or maybe you have some priority packages that have to be delivered before a certain time, or maybe just before noon or something. So you can add a hard constraint for time windows to make sure that we only assign those stops if they can be delivered within that time frame. We've also added here a package type. This is something we hear sometimes where maybe certain packages can only go on vehicles with other packages that are the same, or maybe you have a contract with a certain customer that says that they want a dedicated vehicle only for their packages. That's also fine. So we can do that with a custom constraint. So we'll demonstrate how that works. And the last one we've added here are backlogs. Backlogs are useful for replanning. So if you do your first route planning and start assigning routes to vehicles, and then you get more stops in while you're packing your vehicles, you want to add those stops to existing routes, but you want to keep all the previously planned routes the same for those vehicles. And you can do that in NextMove with backlogs, which we'll take a look at. The last question before we jump into the model is, what should I optimize for? Typically, it's a relatively simple optimization compared to some other types of optimization problems. In our example, we're going to optimize for using the fewest vehicles while minimizing time on road. So we're going to use the time it takes to drive from point to point for the whole fleet, and then impose those penalties for each vehicle that we use and in case there's any unassigned stops. But with next move, you can completely customize the value function to do things like balancing the workload across the fleet. If you have 10 drivers and you know that they're going to be working, it may not make as much sense to say we only want to use 8 vehicles, because then 2 other drivers won't have a route. So maybe you want to evenly balance the number of packages between all of the drivers. You could look at, minimizing costs or maximizing profit. If you're able to take that data and submit it to next move as input, you can formulate a value function that will look to accomplish one of those things as well. So it's highly flexible, but we're going to use basically the default value function here for simplicity. All right, so let's get into the fun part. Let's go build a model together. The final code for this model you can find in our public GitHub repository at github.com/nextmv-io/demos. There's a couple things in there, including this tech talk. So you can go follow along afterwards and just copy paste like I'm going to do here. All right. So we're going to assume that you have not used Nextmove before. I know many of you probably have, but if you haven't, the first step here is to sign up for an account at cloud.nextmv.io/signup. Once you have signed up for an account, you can get started and by installing our local development tools and then initializing a template model. Nextmove supports a lot of different decision models, and we have a lot of different templates you can start from, including a kind of blank slate template model where you can completely design your own. But since we're doing the routing model, we're going to start with routing. You will simply copy and paste the commands here from our page. We've made it super easy to do this. Note that the first time you do it, there's a couple extra steps. You'll just need to refresh your shell environment the first time. Right, and now we're going to install, so we've installed the Nextmove command line interface. Now we're going to install the SDK, which is our Go plugins. All right, and again, note if you're on Mac, you will have to do this the first time, but I've done it before, so I don't have to do it. All right, we're going to continue with the next step is to initialize a routing model. Okay, and we're going to, let's take a look at that model. So this template model has a license file, it has a README to help you get started, a couple of Go files. And then the most important ones are an input JSON and a main.go that we'll be working in. All our models also have a VS Code workspace to make troubleshooting convenient, especially if you use VS Code. So let's go ahead and dive in and see what it looks like. All right, so the model itself is contained in the main.go file. It's relatively short and straightforward. And so we're going to mostly be working here. First part of the model is the input schema. So the structure and schema we have for input here is designed to match our router engine. But we anticipate a lot of customers will want to change this to make it more reflective of the data that you actually have to solve your particular problem. So let's actually go ahead and take a look at the input. Since Nextmove apps basically give you a JSON in, JSON out API, our inputs to Nextmove are all in JSON. You'll see that this is our initial input. It has a lot of things in here that maybe we aren't using. Like, for example, we're not using things like attributes or distance limits or alternate stops. So what I'm going to do is first go ahead and replace all of this input with our input for this demo. You'll see we have about 500 locations. So we have first a configuration. In order to make this a little bit simpler, we've set basically some fleet-wide defaults. So every vehicle is going to start and end from the same depot. Their shifts are all the same. And many of these are similar. So you can set these on an individual vehicle or stop basis. But for simplicity here, we're just setting them fleet-wide. I've set our capacity here to 75 packages per vehicle. And we'll discuss a little more in a second when we look at backlogs, but I've arbitrarily reduced this from the actual capacity so that when we do replanning later, we can fill these vehicles with up to 75 packages now, but the actual capacity is higher. So in the future, when we do replanning and try to add more packages to the route, this way we have some available capacity on those routes in order to continue to add new packages. If we didn't do this, there's a risk that we would already fill each route for every vehicle, and then replanning with new orders would require us to use another vehicle. Also passing through, we're using a duration of 2 minutes per stop. This is probably a little conservative, but we just want to make sure that there's time to make every stop. And I'm also passing here a runtime. This will represent 5 seconds, but we've done this so that you can change the solver runtime for every run. So if you have a small run, you can run for a couple of seconds. If you have a very large run, you can run for longer. But we're just going to pass it in here as part of our input. All right, so we have a list of vehicles and stops. And stops have that type for that custom type constraint that we looked at. And some stops, but not all, have hard windows. So some of these have to be delivered before noon today. All right, so let's go back here. Now that we've seen this, you'll notice, of course, that the existing input structure, input schema does not really match what the data is that we're using for this demo. So we're going to update this to a new input schema that reflects the JSON file that you just saw. All right, so you'll see here now we've got the stops, vehicles, and configuration with each of those parameters that we just looked at. And now that we have changed the input schema, this is somewhat different than what our router engine expects. So you'll see here that these are not necessarily compatible with our router engine. We'll look at that a little more in a second. So in order to pass our input data into our router engine, we are going to create some internal variables that match the structure and the schema that's expected there. But those variables by default are empty, so we will need to populate each of these. Populate each of these data structures with data from our input. That's also fairly simple. We're just going to loop through the stops and populate all the stop related data here. And then we're going to loop through vehicles and populate all of the vehicle related data right here. There are a few other things we'll need to do. Since I mentioned during the slides that we are optimizing for distance, for duration and not for distance, we're going to pass a specific measure that's based on a speed that we're going to pass in our input. This measure is based on Haversign, but NextMove offers a range of measures, including a custom matrix. So what you can do is pre-build a matrix based on your chosen provider of like street distance and duration data, because it might vary if you're using different vehicles like bikes. So you can build that matrix in advance and pass that matrix in. And as of this week, actually, you can now pass in multiple matrices to represent, for example, traffic patterns at different times of day. So the duration to get from point to point may be different during rush hour, during non-rush hour. So you can update this to accept those matrices or multiple matrices here. But we're using just a simple Haversign to make this quick. We also need to implement our custom constraint. So this custom constraint uses a custom type. So this type needs to be created along with a function that's going to define whether or not our constraint has been violated. So we're going to add that here. All right. So you'll see we have this custom type, which is a list of which is a slice of all of the types from all the stops. And then we have this violated function, which implements that custom type. And basically what this is going to do is it's going to loop through each route. It's going to take the label of the first stop on the route, and it's going to look at every other stop on the route. And if the label does not match, then the constraint is violated, and our solver is going to continue to search for a different solution that doesn't violate this constraint so that all stops on the route have the same label. There are many ways to structure custom constraints like this. This is just a relatively simple example, but hopefully it illustrates kind of how it works and gives you a starting point for building your own, depending on your own business needs and rules. Okay, two last things. Now that we've changed all of the options and the data structures for our router, we're going to need to update the both the input data structures here and the options that we're using. So we're using fewer options here, but you can use as many or as few that make sense for your business. So this has everything that we've talked about. So we have vehicle start and end locations. We have those stop durations, which we call services, shifts, capacity, initialization costs. We're using backlogs, and then some of the other features we talked about. And then before we run our model, we're going to do one other thing because we haven't yet accounted for the solver runtime. So by default, we've set a runtime of 10 seconds. We're just going to replace that here so that you can pass a specific runtime as part of your input. If you don't specify a runtime, then the solver will run for 10 seconds by default. But this just makes sure that it doesn't run on forever. All right, so we have all the components here of our model, and we have our input. So let's go ahead and do a quick local test of this model. So you can test this through the Nextmove CLI. We have a couple of commands that I'm just going to copy and paste here, and they're also in the README and in our docs. So we're gonna just run locally with this input, and our output is going to go to a new file called output.json. So this will run for about 5 seconds. As we mentioned before, the bunnies are going to hop and do their best to find a solution for us. And here is our output. So if we look here, you'll see that none of our packages are unassigned. That's great. Everything made it onto a vehicle. And if we look down in our vehicles, we're going to see here that we have used 7 vehicles. But vehicles 8, 9, and 10 don't have any packages assigned. So that's good. We wanted to minimize the use of vehicles. We're not spreading them out among all of them. We're just using 7, which is the minimum that we can use to deliver all these packages. All right, we're going to do one more test, which is we're going to add in here some backlogs. So based on the output, we've created a new input, which includes the previous routes that we planned the first time. These now become backlogs for each vehicle. So each vehicle now has a backlog, which is a list of all the stops that are already assigned to that vehicle based on the first run. We've also made a couple other changes. We've increased the vehicle capacity to its full capacity of 110. So now there's more room available. I've also added 100 new stops. So there's now 600 stops. 500 of those stops are already on vehicle backlogs, and 100 of those stops are available to be assigned wherever it is most efficient. We can also reduce the runtime since we're using backlogs. It's a little bit quicker to compute optimal routes with backlogs. We're really only assigning 100 stops instead of the full 600. So this is only going to take us a couple of seconds to run this backlogs file here. All right, and we've created a new file. You'll see that took a little bit less time. And now we have 600 stops. We still have no packages unassigned. That's great. And if we look through our vehicles, let's go down here again. You'll notice that we are still only using 7 vehicles. Vehicle 8, 9, and 10 have no packages assigned. So this means our upfront constraint of backlogs was effective in limiting, I would say, leaving capacity available to assign new packages in the future. And so this way, we still did not have to use any additional vehicles to service those extra 100 package deliveries. All right, so now that we have tested our model locally and we know it runs, we're going to create an app in Nextmove Cloud that is so that you can have now we're going to make a custom decision endpoint that runs this model in the cloud that we can connect our order management system and routing dispatch system too. Okay, so I'm going to go ahead and create an app that's called package delivery with a name and a description here. All right, and I'm going to go ahead and push this model. I'm going to go ahead and push this model up to our app. So we're going to, this takes a few seconds because we have to cross compile. I'm running on an ARM Mac locally, but our cloud environment runs ARM on Linux. So we're actually going to compile this exact same code to run on Linux in the cloud. And you'll see now that I get a curl command that we can use for both submitting a new run. So I can actually go ahead and submit a run to Nextmove Cloud here. Okay, and now I get back a run ID. So another advantage to running in the cloud versus locally is you can have, they run asynchronously. So you can do scenario planning, you can start multiple runs at the same time with different configurations or constraints. They will all run in parallel. And then you can use their run ID to compare their results. All right, and now I'm going to retrieve the results here. Right, and you'll see here that now I got, again, I got results. So this came from Nextmove Cloud. Now we have a decision endpoint that's running in the cloud on Nextmove. And I can even go into, our console here. And you'll see that I now have a package delivery Tech Talk app where I can track different versions of this app. So if you update your constraints or other aspects of your model, you can track different versions. I can even see the run history, so you can look back on previous runs. And you have an API reference for posting new runs, submitting runs, and updating versions, instances, etc. So this is a unique endpoint that uses your custom model or your custom models, now packaged up as an app in our cloud. All right, so we did it. That was pretty simple. With a little help from copy and paste, we've created a quick model that we can now test and iterate on. Let's talk about a few other considerations before we keep going. One question we often receive is, how often should I run my app? So in order to, and everyone's favorite answer is it depends. So in order to answer that, you should consider a few things. In our case, since it's package delivery, when and how often do you pack your vehicles? What's your planning horizon? And when and how often do orders come in? So if you pack your vehicles basically once a day, and it happens for a few hours before shifts start, and your planning horizon is the whole day. So the vehicles depart the depot in the morning and they come back in the evening. This is very feasible with trucks, and maybe not so feasible with something like bikes. Then you're likely only actually running planning and replanning a few times during the day. You might run the first time when you need to start packing your vehicles. And if you have orders come in every 30 minutes or every hour after that, you may run again every 30 minutes or every hour. That is if you're planning for a full day. If your package delivery is more of a bike or a small vehicle scenario where they're going to have to come back to the depot multiple times a day, and you may be getting new packages in or new orders that need to be shipped out, you're going to be running much more frequently than someone who's planning for a full day. All right, so a few things you could take away from this tech talk. So Nextmove offers many configurable routing constraints out of the box, which we looked at. But you can also completely customize your delivery model for your exact requirements, whether that means custom constraints, custom measures to account for things like traffic, or a custom value function to optimize for something other than simply minimizing distance, like maximizing profit or minimizing cost. And you can also build and deploy a custom routing model for package delivery in under 30 minutes. And I would say it's 11:25 my time, and I would say that happened in about 20 minutes. So with the magic of copy and paste. All right, so now we can get to some Q&A.
Yeah, thank you so much, Joe, for that wonderful demo. And just as a reminder to folks, the final code that Joe just used is available in our public demo repo. And the link to that code plus the recording of this presentation will be available in a post-event email that will be sent out to you shortly. So don't worry, you can get started right away. Okay, let me take a look at the questions we have. We have a few. Okay, Joe, the first one, do you have any considerations for runtime?
Yeah, runtime is a question we get fairly often. So runtime for the solver is going to vary depending on the size of your model. It obviously takes a lot more time to optimize 10,000 stops than it does to optimize 100. But it also depends on how fast your business requires you get an answer and get a solution. So in a package or parcel delivery, you usually have a little bit more time. You're usually not needing an answer in a few milliseconds or a second, in the way that you would with something like a food delivery app that's constantly changing all the time. So you may start out, running for 30 seconds or a minute, and then evaluate the results. So we just recommend running some tests with different sizes of inputs that are typical to your business. So the typical number of stops and vehicles, and run at a few different times that are acceptable within your business limits to get a response, and see when you get a good response with good high quality routes.
Great. Okay, the next one here we have, we did get a question about avoiding certain pathways and if that's possible with Nextmove. And I believe the answer is yes with Routing Kit, but I'll let you dive in a little bit deeper there, Joe.
Yeah, so there's a couple aspects to that. The first one is for planning purposes. Nextmove does not necessarily create turn-by-turn directions designed to send to drivers. However, I did mention that custom matrix, so you actually can use any distance and duration sort of provider that you want. So you can, if you have a custom like OSRM package built that will avoid those pathways, you can build that you can build a distance and duration matrices that specifically avoid those. And so the time and the distance will be different for taking a different route. And that data will be accounted for in your input matrix when you submit those to a measure with Nextmove.
Okay, I think we have time for just one more question here. We did get a question about grouping stops by region. So drivers each have their own zone or geographic area. Is that something that's possible with Nextmove?
Definitely, yeah. There's several ways to do that. So you could, if you have advanced knowledge of what those zones are, you can actually predetermine those zones. We have a function called compatibility attributes. You can assign a driver a specific attribute, and then you can pre-assign any stops that are in that zone or region with the same attribute. That way, all of the stops get assigned to that particular driver. They may they may be assigned other stops that don't have attributes, but if all of your stops have attributes and all of your drivers have corresponding attributes for regions, then they will be assigned accordingly. We also have just released, if you actually want to do some zoning or clustering, you can also with Nextmove take all of your stops and create some clusters, and then assign those clusters as routes to individual drivers. So there's several ways to accomplish that.
Perfect. Okay, I think we're just about at time here. So I wanted to say thank you everybody for joining, and head to nextmv.io for more resources, including recorded sessions that are now available to you on demand. So we have more Tech Talks coming soon. Keep an eye out in your inbox for the next invite. And thank you again. We will see you next time.